Well, good evening and welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope everybody's had a fantastic week. I've had a good week. It was 23 degrees here and full on sun yesterday. The first day this year I've been able to go out in a t-shirt. It was quite wonderful. But predictably today it's back to 11 degrees and grey. But there we are. That's life. So this evening I'm joined by Roger. Hi, Roger.
Good evening.
And Michael.
Good evening.
Mr. Hot Yoga himself, for reasons that we won't go into. And Lou. How are you, Lou?
Greetings. Just weathering another deep cold on the East Shore.
Oh, it will get better. It must. Anyway, so here we are again on a Tuesday. This evening, Lou is going to be talking to us about the asteroid that's been very much in the news recently, 2024 YR4, because there is a decidedly non-zero chance that it could collide with the Earth on its approach in 2032. But Lou's going to talk about that, but he's also going to be talking about other asteroids in the solar system which potentially might cause us problems in the future. So thank you for that, Lou. We'll come to you in a second. In the meantime, let's just go on through a few things. Thank you to all of you who have been sending in photos to our gallery. We haven't had many in this week for the gallery. Well, one to be exact, and that's a bit of a disappointment because we need to give Roger some work because otherwise he just sits and watches TV all the time. So we need to keep him very active if we can. So if you have any images that you would like to share with us, any astro images, put them in an email, one per email, please. Attach them to an email, that is, rather than paste them. And send them to gallery@spaceoddities.space because we love showing your images, and I'm sure our other viewers love seeing your images too. And of course, if you send us your images, you get your own free gallery on our Space Oddities website. So it's somewhere you can share your work with others and see how brilliant an astrophotographer you are. Don't forget as well that we have the Space Oddities shop where you can buy absolutely stunningly amazing Space Oddities merchandise, and you can click or you can scan the QR code here, and a link for that should have just appeared in the chat. So we've got t-shirts and hoodies. T-shirts at £25, including UK postage and packing, and hoodies start at £40, including UK postage and packing. All money that we receive goes towards keeping the channel running because we have bills to pay like any other YouTube channel has bills to pay to various people. But don't forget as well that you can buy us a coffee. If you would like to contribute to our caffeine intake, and God knows we need it, then you can again scan the code or click the link, and that will take you to the Buy Me a Coffee site where you can buy me a coffee. We'd like to say a big thank you to those of you that buy us coffees on a regular basis. Much appreciated. Don't forget, you can also donate directly to Space Oddities by clicking the Super Chat link underneath the chat window, which is the one with the $sign on it, and that will allow you to make a donation to us without any hassle whatsoever. So thank you for that. Very kind. So I think without more ado, because Lou has to go off teaching in half an hour, so let's move over to Lou. Just before you start, Lou, this asteroid's been a lot in the news recently, and there's been a lot of not exactly misinformation, but a lot of writing about it where the writers haven't bothered to check their facts. I've seen things that say that the asteroid is the size of a planet. I've seen others that say that it's got an orbital period of 2 million years. All sorts of stuff being shared which just isn't true. But I think the main question, Lou, that people would like to have answered is it going to hit us?
And you will get the facts here on Space Oddities. You will.
Okay. So,
only the facts and nothing but the facts.
The facts and nothing but the facts. That's what we're all about. So when you're ready, Lou, we can...
Let us begin.
Okay, so...
It comes right up. This is technology at its best. Well, I'm sure unless you have been living on the moon and underground, you no doubt have heard about this latest asteroid, 2024 YR4, that is it's a near Earth asteroid, or near Earth object. NEA or NEO is the abbreviation, and
Can I
has
just stop you
chance.
a moment, Lou? We're only seeing the slide design screen, not the slideshow. It's a bit small to see.
Huh. Okay, I'm seeing the full screen on my
Right. Okay. One
computer.
second. I think you'll have to stop sharing and do it again.
All right. I think let's see. Have I? Here we go. Okay, stop sharing.
There we are.
Ooh.
Oh God! Somebody.
How did that happen?
Yeah.
I don't know.
It's like magic.
Hey everyone.
Ooh.
Has somebody been duplicating a key to the back door? That's what I want to know. Reach me. We'd like to welcome Tom to Space Oddities again. You may remember Tom was here last week. We talked about his wonderful astrophotography app.
Hey
Pig
guys. Hey.
And,
Sorry for being a wee bit late.
a substantial amount of money, and he decided to come back. So, so you're more than welcome, Tom. How are you? How's your week been?
Really good, actually. Apologies for the glitches there. The link kind of glitched out on me a little bit, but I managed to put 50 pence in the meter, so I'm here now. So that's
fantastic, fantastic. Those were the days. Right, you're set now, Lou?
I think so. So I'm sharing, and you see the
No, so hasn't no change.
right. So let me try.
Right, okay.
Try.
Apologies, viewers.
Did it just change?
Of live streaming? No,
No.
no.
Isn't that odd? I wonder if that's because I'm using an external screen. Well, I don't know. I tell you what, we will do it this way.
Okay.
We'll just do it this way. There's always a way. Okay. So
Right. That's
back
great.
again. Unless you've been living on the moon and underground, you have heard about Asteroid 2024 YR4, a near-Earth asteroid which has some chance of hitting the Earth. And when, as Andy was kind of intimating, anytime the news media gets a hold of these kinds of things, no matter what the odds are, it sounds like doom, like we're all doomed. And of course we are, but not, I don't think, by this asteroid. So let me just walk you through a little bit about how we find these near-Earth asteroids, what they are, and what threat they pose to the Earth, and then we'll close down a little more specifically by talking about YR4. So here we go. So there are really four kinds of near-Earth asteroids, all right? Armor, Apollo, Aten, and Atira. Now, the Armor and Atira, they're nothing to worry about or even think about. Armor near-Earth asteroids orbit entirely outside the Earth's orbit. Atira near-Earth asteroids orbit entirely inside the Earth's orbit, so they're no threat at all. So the ones that we'll be kind of focusing on today are the Apollo, which are Earth crossing with large semi-major axes, and the Aten, which are Earth crossing with smaller semi-major axes. Okay. So just kind of get an idea, get a feel for near-Earth asteroids and what we're talking about. Here's a graph showing the number that have been discovered by date and a little bit of information about their size. These are 1 kilometer and above, 140 meters to a kilometer, and then kind of everything else with all the smaller stuff. So you can see we're doing quite a good job at finding these. We have ground-based systems, I'll show you a little bit of that are looking for them. We have space-based systems that have done a great job in identifying these near-Earth objects or these near-Earth asteroids. So we have quite a lot of information about this. Now, here's what I want to know, and let's see if I can play this video. We'll see if it plays for you all. Are you seeing text on the screen?
Yes.
Okay, maybe this will play. This is a representation by time of how many near-Earth objects we have discovered and their orbits. So here we are in 1999, ancient history. And these are all actual ephemerises of these objects. 10 years later, we know a lot more. a lot more in 2018. You can see the orbits of Mercury, Venus, Earth, and Mars, and Jupiter there.
Oh my
And then,
goodness.
Wow.
yeah, there are lots of these. Now, the ones in red here are the belt asteroids. We're not really concerned about those, and they don't represent any threat to the Earth. But this is what JPL does, and we'll be talking a little bit more about their work in a minute. Okay. So all these near-Earth asteroids, but what we're really concerned about are the ones that represent a threat to the Earth. And these are called potentially hazardous objects or potentially hazardous asteroids, PHOs or PHAs. And we define these as asteroids that, again, intersect the Earth's orbit at distances of 0.05 astronomical units or less, all right, about 20 lunar distances. And we also define these as objects that have absolute visual magnitudes of greater than 22, or what we estimate to be sizes, diameters of 140 meters or more. And this is because many of these, we are estimating their size based on their albedo, based on their reflectance. So we make an assumption about the surface material and the surface properties, and therefore we say at this distance it should be reflecting this much light if it's this big. So it's kind of an indirect way of measuring the size of these things, and we have much better ways as well. So as of November 2022, there are 2,304 known potentially hazardous asteroids. So about 8% of the total near-Earth population. Okay, 153 of these are larger than 1 kilometer in diameter, and most of the discovered potentially harmful, hazardous rather, asteroids are Apollo-type asteroids with Earth-crossing orbits, about 2,000 of those, and some with shorter semi-major axes are the Aten asteroids, about 185 of those. But here's the good news. More than 99% of these are no threat at all to the Earth in the next 100 years. Okay, so you can rest easy with that knowledge alone, I think. Now, so we oops, let's see. There we go. We categorize these in a number of ways. This is called the Torino scale. And basically, it puts these asteroids into buckets from no big deal to run for your lives, okay? So the no big deal asteroid, and by the way, the material is coming into Earth's atmosphere daily, every hour. I mean, we are getting smeared with small, tiny, micro asteroids, things that are very tiny hitting the Earth's atmosphere. This is not news. This is not news. But every now and then we get something a little bit larger. And it turns out, looking at this scale, that the larger the object, the less abundant they are in the solar system. So that the ones that would really cause a problem here on Earth, there just aren't many of them. And their frequency of hitting the Earth historically is in terms of hundreds of thousands to millions of years. Okay, and as I'll be showing you later, asteroid YR4 is a level 3 on the Torino scale, which, as they say, merits a little bit of attention. So here we have the Sentry monitoring system. There are 32 objects in this database that we are watching very closely. The very top one, as you can see, is 2024 YR4. And if we go all the way over to the right to the Torino scale, we see that it is a level 3 on the Torino scale. But look at the rest of these that have values. They're all level 0, which means they're probably not much to be even interested in. But NASA and ESA and other groups are tracking these. But the only one of real interest, I guess you'd say, in this database is YR4. So if you want to have a little fun with this, JPL has a really wonderful set of applications. There's eyes on galaxies, eyes on the Earth, eyes on the solar system, and this one is JPL Eyes on Asteroids. And I can't play with it here in this format, but if you go to the JPL Eyes on Asteroids, you will get a 3D modeled image of not only the asteroids in our solar system, but the space missions that are tracking them. And you can click on these, see what they look like, see where they are, and play a little bit with the time scale to see when they might come close to Earth. So sorry I can't show you that here. Okay. Let's get into a little more specifics of Asteroid 2024 YR4. This is the tracking sequence from the Atlas system that tracks near-Earth asteroids. There are 4 of these telescopes on Earth, 2 in Hawaii, one in, one in South Africa, and one in, now I'm forgetting what the other one is, but there are 4 of these. These images were taken with one of the Atlas telescopes in Hawaii. And so you can just see this moving across the rather static background of stars. Here we see a graphic representation of the orbit of 2024 YR4, and up in the upper left you can see the date. And as it swings around in its highly eccentric and rather inclined orbit, by the way, you can see when it's expected to come very near Earth in the year 2032. I do find this interesting that the orbital inclination is 3.4 degrees. That's nothing to sneeze at. So it just so happens that it's intersecting Earth's orbit at a time when Earth will be there.
Doesn't look good, does it?
I'm hearing a lot of concern in our panel. We'll get there. Here's another way of looking at it. Here, the red circle, that's Earth's orbit. It's almost an actual circle. It's only very slightly eccentric. And then in the blue oval here is YR24's orbit. So you can see on the right-hand side here where things were when the asteroid was discovered and where things are expected to be on December 22nd, 2032. If you go to the NASA JPL Center for Near-Earth Object Studies, you can get some information on this YR4 asteroid. There's a little bit of fudge in the actual date that it will hit the Earth at this point, but it will be in December 22nd, 2032, we think, is the next close encounter. The size of the asteroid is still a little bit to be determined. And again, this is because the current estimates we have are based on the albedo or the reflectivity of the asteroid, how much light it's reflecting back to the Earth, and our estimates of the surface material that's doing that reflecting. So we make some kind of an estimate of how big it would have to be given those assumptions. But there's a little bit of slop in that, as you can see. It's a stony asteroid, okay? And its impact, again, a little uncertain because we're uncertain of the size and also the bulk density. But perhaps something like the Tunguska asteroid that flattened about 800 square miles of the Siberian force in 1908. So they kind of call, I don't want to get too blustery here, but this would be, if it hit a major city, it would be like bad news for that city, okay? But this is not an asteroid that poses any threat to life on Earth, as we've been hearing in some reports. The James Webb Space Telescope will be looking at it. It has emergency priority to look at this asteroid to try to get a better sense of its size. JWST can do this even as the asteroid is moving out away from the Earth, get a much better estimate of the size. And then, of course, when it moves back toward Earth, active radar measurements will give us a very precise estimate of its size. It turns out that this next item here, odds of hitting the Earth, is a little bit out of date. It seems that each time we make an estimate or an estimate is published, it goes up a little bit. Okay, it was at 1.5%, then it went up to 2.2 and then 2.3%, and now latest estimates are about 2.6%, or one out of 38 of hitting somewhere on the Earth, and it even has a possibility of hitting the Moon, which would be very interesting and would probably cause some very exciting meteor showers here on Earth.
Yeah, but knowing our luck, Lou, it'll impact on the far side.
Hopefully. So here's another way of looking at it. Here we have basically the Torino scale in different colors here. On the x-axis, the probability that an asteroid would hit us. And on the right axis, the kinetic energy, how fast it would be moving times its mass. And as I pointed out here, the YR4 has a Torino scale of 3, something to watch. But right now, nothing more than that. This is a picture of the Atlas, one of the Atlas telescopes, this one on Mauna Loa, that track these kinds of things. And you can see a little bit down on the lower left-hand side here of the discoveries that it has made, that this system of telescopes has made over the time it's been in operation. When a discovery is made and it's tracked for a while and they have some sense of its orbital elements, this is where it goes. It goes into this publication of the Minor Planet Electronic Circular, and that provides information for other people to and other space systems and Earth-based systems to explore, to get better and better constraints on the orbit. If this is of interest to you, you can actually go to these telescopes' websites and find out what they're discovering and what they're imaging in real time, or very near real time. So I just picked one. This is the Haleakala Atlas on Mauna Kea, and it shows kind of what it's looking at and where it's scanning and what discoveries it's been making and this kind of thing. So that's kind of fun to do. Now, so far I've been talking about ground-based observatories. We do have the NASA WISE spacecraft. See, here it says NEOWISE. This is the Wide Field Infrared Survey Explorer spacecraft that was kind of repurposed to not only look at all asteroids, but to look kind of more specifically at near-Earth asteroids. Okay. It was launched in 2009, and it's had a couple of different missions and mission redirects, and it's now ended its lifetime. But it provided us with a lot of great information on the orbital elements of potentially of concern near-Earth objects. And I'll just end with this here. Here are some of the discoveries that it made. Not all of these are in fact, most of these are not of any concern, but these are the kinds of numbers that a space mission like WISE, which was targeted as NEOWISE, Near Earth Object Wide Field Infrared Survey Explorer, made during its lifetime. And there will be follow-ons to NEOWISE to do even more search and identification. So the bottom line is for this one YR4 that we're not really at much of a risk at all of it hitting the Earth. And I think I went by one slide. Yes, I did. Here we go. Here is the estimate of where it could hit in the year 2032, this red line here. And some of the major cities, population centers along that path have been identified here. So it goes through actually a large stretch of the Atlantic Ocean and partly of the Pacific Ocean, but it does intersect Earth and in some cases some populated areas. So we will be watching this. We will be getting better data on it, better orbital elements, better estimates of its size and composition, and we'll be reporting it, of course, to you on Space Oddities.
For as long as we can.
As long as we live. Yes.
Great. All right. Well, listen, I think the bottom line with this asteroid, is it not, is don't even give it a second thought at the moment, because there's still so much uncertainty over its orbit. And we won't know more until 2028 when we're able to more accurately plot its orbit.
But if you are concerned and you feel your life slipping away, send us your money, send us your retirement.
Send us your money.
We will put it to good use here on Space Oddities, informing the public.
Yeah,
Just
absolutely. And with that money we can buy Tom a new wig, and and wigs are not cheap, as you know. So
they're really expensive. I've got
indeed. So there we are. So basically, don't worry about it, viewers. It's not in the grand scheme of things, it's not really something you should worry about in life at the moment.
We're all doomed.
We're all doomed.
Yeah, I see this comment from Graham. If this is Lou trying to cheer us all up, I'd hate to hear him when he wants to worry us. Well, that's not quite the message I had wanted to convey. But
So absolutely, Graham. But Lou isn't one to ever want to panic people unnecessarily. And as we say, what do we give you on Space Oddities? The facts. Never anything but. So we're not trying to worry anybody. But the fact remains that this asteroid at the moment is somewhat a little bit of a threat, but nothing to lose sleep over. I did, talking about threats, I did see this week that there is a supermassive black hole on a collision course with the Milky Way in the Large Magellanic Cloud, which is being gravitationally attracted into the Milky Way. And when that happens, it will sink towards the center of the Milky Way and merge with the supermassive black hole, Sagittarius A star, at the middle of the Milky Way. This is not something you should worry about again, because it's not going to happen for 2 billion years. So, nothing really to get upset about. So all of these astronomical threats are, they're not worth worrying about. However, we will know more in 2028. And if there are any developments, we will keep you posted. The thing about this possibility, the 2.3% or whatever it is with asteroids, is that quite frequently happens with these threats, that the percentage goes up but then goes down again as its orbit is more clearly defined. So don't worry at the moment. We just want to say that, don't worry. So anyway, thank you very much for that, Lou. I gather you're going to go off and scare your students now.
Yes, we're going to study the inner solar system today, so it's perfect timing.
Oh, I wish I were in your class.
Oh, come on over.
Yeah. I bet they're great. So there we are. We will see you next week, Lou.
All right.
And we'll have even more fun and scare even more people.
Thanks, Lou.
You're all.
Bye, Lou.
Take care, Lou. All the best. Have a great week.
Bye for now.
Bye, Lou.
So there we are. So there goes Lou Mayo, planetary scientist. So
Thanks
he
for
knows what
that.
he's talking about. So there we are. So Tom, we didn't ask you, how's your week been, Tom?
It's been really good, actually. I'm just looking through. So I was doing an image accessing session about 2 months ago when I was doing Spider and Fly Nebula. And I never ever check my registered subs, but this occasion I decided to check my registered subs, and there was an asteroid called 15. I've got my notes here actually. 15 Eunomia, which is one of the biggest asteroids in its class, which orbits every 50 or 60 years or so, that I managed to image during an image session.
All right.
Really?
Yeah, and it's estimated to contain 1% of the total mass of the asteroid belt. So it's a biggie.
Ooh, gosh.
That's a
big-
lot.
Yeah,
Hmm.
15 Eunomia it's called, which is
Yeah.
a very large asteroid, according to NASA.
Ooh.
Yeah.
So really, don't worry, don't
No,
worry.
no, don't worry.
But
Don't
the
worry.
fact that my 8-inch newt was able to capture it slightly worried me.
Yeah, I'm sure. But viewers, I mean, have you, anybody out there has observed an asteroid? Have you done any asteroid observations? Do you have any images of asteroids that you've managed to capture?
Hmm.
So if you have, you know what to do. Send them into gallery@spaceoddities.space. Attach them to an email, and as I keep saying, not only do you get to see them here on our Tuesday live stream, you have your own gallery on our website automatically, unless you tell us you don't want it, of course. Obviously, if you don't want your galleries, your images displayed on our website, then tell us, no problem. Okay, right, well, let's move on. So I think next on the agenda this evening is the news. So let's have a look at what we've got. Not too many news stories this week, but there's been some really interesting ones about exoplanets this week that I'd really love to talk to you about, because it's some fantastic stuff been going on. So just give me a second to set this up, and we will have a look at the news for this week. I hope you can all see that.
Yeah.
Let's just maximize that. Get our ugly mugs out of the way. Okay, so this is the news for the 18th of February. There's been a major gravitational wave event. Now, just to put some context on this, if we go back to GW 170817 in August of 2017, this was known as the first multi-messenger event, whereby the collision of two neutron stars in a cataclysmic collision that ended up generating through nucleosynthesis 200 Earth masses of gold and about 500 Earth masses of platinum. This was the first so-called multi-messenger event. And what does that mean? It means that we were able to observe it not only in gravitational waves, which arrived first, but gamma rays, radio waves, and optical wavelengths, because astronomers actually tracked down on the sky where the event was, and it was in a galaxy called NGC 4993, and they were able to watch this titanic explosion happen. And this was a major step forward, because it was the first time that gravitational waves had been used to detect an object, which was then thereafter viewed all sorts of different wavelengths. This one has the, of course, the obvious name of S250206DM. So I'd just like to tell you a bit about these multi-messenger events. So these are events from which we can detect three types of things. We can detect electromagnetic radiation, visible light, X-ray, gamma rays, etc. We can detect particles such as neutrinos or cosmic rays, and also gravitational waves. We've never had an event where we've managed to detect all three until now. So this is why it's absolutely so significant. So the background to this, it happened on February the 6th. And the LIGO and Virgo detectors in the United States, they observed this event, and it was immediately classed as a probable neutron star black hole merger. And the false alarm for this type of event, which means how often you would expect a false alarm, is about every 25 years. And they managed to track down its location to within about 546 square degrees at an estimated distance of 373 parsecs, give or take 104. So not a long way away. The resulting object, almost certainly a new black hole, has a combined mass of between 3 and 5 solar masses. So it's on the really low side for these events. So it's almost certainly a black hole, but it could be a heavy neutron star, but astronomers think that a new black hole originated from the event. Amazingly, less than 5 minutes after the gravitational wave detection, the Ice Cube Observatory in Antarctica reported the possible detection of neutrinos from the same area of sky. And one of these neutrinos, they're not sure about the others, but one of these neutrinos has an exceptionally high probability to be related to the gravitational wave event. Now, Ice Cube is a neutrino observatory in Antarctica, and it consists of detectors going, hundreds and hundreds of detectors on strings going way down into the ice to insulate the detections from terrestrial sources of neutrinos, because neutrinos can be generated naturally on the Earth. But if you don't know what Ice Cube is all about, this is what Ice Cube looks like. So you've got the top, and the strings go down 2,500 meters into the ice, and each string is made up of these optical modules. And what they're looking for is tiny flashes of light as the neutrinos pass through the ice and interact with an atom of some type. Now, neutrinos are exceptionally ghostly particles. They can pass through light years of matter without even knowing it's there. Every second of every day, literally trillions of neutrinos are passing through your body. And they have been called the ghost particle because they don't interact with matter. Very, very rarely do they interact with matter. But this is why the Ice Cube Observatory is there, to detect these rare interactions with matter when neutrinos collide with an atom, and it generates a tiny flash of light. So these detectors are photomultipliers that are incredibly sensitive to the tiniest of flashes. And this is where they detected it. There are over 5,000 of these detectors embedded in the ice. They're just waiting for clearance to double the size of this observatory, which will make it even more sensitive and likely to detect, obviously, twice the amount of neutrons statistically. So that's the Ice Cube. Now, after that, after the neutrino detection, I have to stress that it's yet to be confirmed that the neutrinos detected were related to the gravitational wave event, the merger between a neutron star and a black hole. In Canada, the CHIME radio telescope array reported at about the same time one of these fast radio bursts, the FRBs, which are incredibly brief flashes of radio light lasting a fraction of a second that are going off across the universe every day, all the time. And CHIME was built really to detect these FRBs, among other things, but it's had a very good record at detecting FRBs. We don't know what the FRBs are all about. We don't know what generates them exactly, although more and more astronomers are coming to the conclusion they're generated by magnetars, these incredibly magnetized neutron stars that could pull the keys out of your pocket from as far away as the moon. And the FRBs seem to be associated with magnetars, although there's a long way to go yet. The CHIME telescope in Canada looks like that. It's a big radio array, and it's not actually fully operational yet, but it's already detected many of these fast radio bursts that we're trying to understand. So if the neutrinos and the fast radio bursts are confirmed, at the moment there's a bit of confusion about the CHIME data, because it seems that although there was a first fast radio burst at about the same time as the gravitational wave event, they are still trying to confirm that it happened in the same area of sky. So we're not sure about that. But if it is confirmed and the neutrinos are confirmed, it will be the first multi-messenger event where we've received electromagnetic radiation in the form of the fast radio burst, particles in the form of neutrinos, and gravitational waves. So this would be quite a major event in gravitational waves, that we can now use gravitational waves as a proper observatory to observe these events far off in the cosmos. And of course, gravitational wave astronomy is in its infancy, but I won't go into that because I've talked about that many times before. but I will keep you updated on this gravitational wave event and whether in fact all the data bears out. So a lovely image from the JWST. What you are looking at is a protoplanetary disk in Orion, which is edge on to us. So it's sort of cigar shaped. And this is a new solar system being formed, probably. And what they've detected at various wavelengths using the 4 infrared wavelengths that the JWST observes in, they've detected a large quantity of water ice in this protoplanetary disk. And you can see one of the wavelengths on the right, and they put the 4 together to build the image on the left. And guess what? That white, those white areas in the disk are thought to be water ice. So there is a huge amount of water ice in that protoplanetary disk. And obviously this raises the question, is this the same with all protoplanetary disks? Is this where all the water on the Earth originated? From the solar nebula when the sun and the earth were forming. Wonderful image from the JWST. So I just thought I'd show you that one. A bit of a breakthrough in the study of exoplanets. Astronomers have managed to map the atmosphere in an exoplanet in 3D. So this is the first time this has ever been done, and it shows you how far the science is coming along, that we can now do things like this. So let's have a look at the details here. So this is the first time a 3D structure has been mapped on an exoplanet, and it was done by combining the 4 telescopes at the European Southern Observatory's Very Large Telescope, or VLT, and they found powerful winds carrying chemical elements like iron and titanium, creating intricate weather patterns across the planet's atmosphere. The discovery opens the door for detailed studies of the chemical makeup and weather of other alien worlds. And the director or researcher who was part of this team said basically, it will give us a greater understanding of how weather works on planets, but it's really challenging what we thought we knew about weather on different planets. And this is Julie Victoria Seidel, a researcher at the European Southern Observatory, where the Very Large Telescope is. And that was published only today. This planet is catalogued as WASP 121b, but they've given it a name. It's called Tylos. I'm not quite sure where that name comes from. It's about 900 light years away in the constellation of Puppis. It's an ultra-hot Jupiter. It's a gas giant orbiting its host star so closely that a year on that planet lasts only about 30 Earth hours. One side of the planet is scorching hot, where it faces its star, and the other side is cooler, but it is tidally locked to its star, meaning that the same side always faces the star. And just a bit more information. So they probed the atmosphere and they've revealed distinct winds in separate layers. And they've been able to make this map of the atmosphere's 3D structure the very first time this has been done. And what they found was a jet stream rotating material around the planet's equator. A separate flow at lower levels of the atmosphere moves gas from the hot side to the cooler side. This has never been seen before on any planet. And the observed jet stream spans half the planet, gaining speed and violently churning the atmosphere high up in the sky as it crosses the hot side of Tylos. Even the strongest hurricanes in the solar system seem calm in comparison. And that was a quote from Seidel again. And to uncover this structure, they used the Espresso, note Michael, Espresso, instrument on ESO's VLT to combine the light of the 4 large telescopes into a single signal. This is what the European Southern Observatory have produced. So we're looking down on top of the planet now, and it's rotating anti-clockwise as seen from the Earth. And you see you've got 3 distinct layers there of elements being moved around the planet. You've got iron, sodium, and at the top a layer of hydrogen, which is escaping into space. And just to put some more information about that, so don't forget, it always shows the same side to its parent star. So it's always day on one half of the planet, and it's always night on the other half of the planet. The transition between night and day is the morning side, while the evening side represents the transition between day and night. Its morning side is to the right in this graphic, and its evening side is to the left. And as the planet crosses in front of its star, atoms absorb specific colors or wavelengths of the star's light. And this was what was measured with a spectrograph. And from this, astronomers can reconstruct the composition and velocity of different layers in the atmosphere. The deepest layer is a wind of iron that blows away from the point of the planet where the star is directly overhead. Above this layer, there's a very fast jet of sodium that moves faster than the planet rotates. And this jet actually accelerates as it moves from the morning side to the evening side of the planet. And then, as I said, there's an upper layer of hydrogen wind blowing outwards. And they found all sorts of other elements in the atmosphere, including titanium and others. So I just thought I would share that with you, because the ability to do this, to map a planet orbiting another star, its atmosphere in 3D, is science that would have been unthinkable just a decade ago. So it just shows how quickly the science is moving on. This is quite wonderful news that we can now do things like this, and I'm sure many big discoveries await. And we're staying with other planetary systems, because the JWST and ALMA is the 66 dish millimeter submillimeter telescope in the Atacama Desert in Chile, and they've joined forces to reveal stunning details in the PDS-70 system. This is a planetary system with 2 planets. We can see them there in that graphic. The star in the middle, of course, is blocked out. Its light is blocked out so that we can see what's going on. Otherwise, they couldn't have made the observations. The orange part of this observation is from the JWST, that is infrared, and the purpley part of the ring is submillimeter radio wavelengths from ALMA. And if you look at the bottom right, you can see the orbital radius of Neptune, so you can see just how big this system is. And what they're saying about this is that this will give us new insights into how planets actually take shape. And this study has been done by Canadian astronomers at the JWST end. This is the teams led by Dory Blakely, who's a PhD candidate at the University of Victoria. And they uncovered key details about these worlds and the distribution of gas and dust from which those new planets are emerging. And this system is only 5 million years old. So this is a really, really young planetary system. And you can see there's a gap in the middle. The dark area surrounding the star is where these 2 planets called PDS-70b and PDS-70c. Don't forget that the star is always A in a planetary system, and the planets are therefore lettered B and C and D, B being the closest and other letters in the alphabet being further away. So this is really exciting news. And what Dory Blakely said about this was, we're seeing snapshots of the early stages of planetary growth, showing us what happens as worlds compete for survival in their cosmic nursery. But the amazing thing is not that we can see these planets, but we can see the actual process of their formation. And as she said, they're competing with their star and each other for the gas and the dust they need to grow. But another interesting thing is, if you look at the actual images of the planets, you see that they're not circular. The 2 planets, B and C, seem to be surrounded by a ring of dust, which indicates that they've got moons forming around those planets. And this is the first time that we've ever seen that. The red yellow glow, based on the JWST data, reveals the growing planets and light scattered off tiny dust grains on the surface of the disk. They're so small they scatter light mostly forward, which is why we can't see the far side of the disk, because the light scattering is pointing away from us. The faint blue ring is from ALMA, as I said, and that represents cooler emissions from larger dust grains located throughout the disk. and at the heart is that central star. And the circles around each planet, by the way, the dotted circles around each planet represents where ground observations predicted those planets were. And as we can see, they were absolutely spot on, because they're exactly where ground observations predicted they would be. And then the JWST saw them. And there we are. So this is another step forward in the study of planets and planetary systems around other stars. So there we are. So that is the news for this week. There are a couple of things that I want to just mention that I didn't have time to get into the news. And those are that the Blue Ghost moon lander has actually left Earth orbit now and is on its way to the moon. I think Mark, was it March the 2nd? I think it's due to land on the moon, if I remember rightly.
March 2nd or 3rd, something like that.
Yeah. So I hope you'll join us on Space Oddities, because we will cover that live, even though the landing is happening at 3 o'clock in the morning UK time. But we'll be here nonetheless to cover that moon landing by the Blue Ghost lander live.
Yeah.
Roger's shaking his head quite violently there, meaning he won't, because he'll be in bed with his Horlicks, I'm sure. So
yes, Ian's on the sorry, Tom's on the
other drinks are available. I prefer hot chocolate myself.
Oh, you're a hot chocolate man, are you? So there we are. Oh, Ian, thank you for that. There we are. Ian's looked it up, and Tylos, the name that's been given to that planet, means Bahrain. It's the name of Bahrain in ancient Greece. So there we are. Thank you for that, Ian. Useful to know. So anyway, yes. So yes, we will be with you on the morning of March the 3rd, I suspect, and we will cover that landing. Of course, it's not the only vehicle going to the moon, because there's a Japanese moon mission that was launched at the same time, and I'm not quite sure when that's getting there. I think it gets there ahead of Blue Ghost.
I don't think it's that far away, actually.
No, it's not.
Between them, what a rest.
It's Hakuto, isn't it?
Landing for Blue Ghost is definitely March the 2nd.
Right.
Yeah. Just bear with me. Can't see a time.
No.
Okay, I'll find out the time.
Yeah, if you could, we'll confirm it next week. But as you know, we do try and cover all of these major events live, and anything landing on the moon is always a major event. And then we've got later this month, we've got the launch of the Intuitive Machines IM-2 mission to the moon as part of NASA's commercial lunar payload services. And there are loads of different payloads on that lander. Some very exciting ones. We'll be talking about that nearer the time. But again, we'll be covering that launch later in the month, and obviously the landing a bit later as well, which will probably be in March as well, because I think the projected launch date for the IM-2 lander is, I think it's actually February the 28th, if I remember rightly. So
we'll get that.
Yeah, I don't think it's been confirmed yet, but they were talking about the 28th. So we will see. But I mean, it's going to be a really interesting time over the next couple of years for lunar exploration, because there are 13 countries going to the moon over the next few years, and we will be talking about that very soon on Space Oddities. Just let us run an idea past you, viewers, because we do love your opinions. And if you could all give your opinions on this so we can get a decent gauge of it. What we're considering doing on Space Oddities is having a dedicated moon month where we'll be creating live streams and videos and presentations and all sorts of things about the moon, covering many aspects of the moon. Is this something that you would like to see on Space Oddities? Would that interest you? So if that would, please say yes or no in the comments. Anybody who says no, no problem. We are asking you. So we just want to see how much support for it there is among our viewers. So if you'd like to see a dedicated moon month where we tell you everything we possibly can about the moon, its history, the missions that have been to the moon, the missions that are going to the moon, all sorts of things about the moon, then please say yes in the comments. And if not, please say no as well, because we'd like to see how many people are actually taking part in this little poll. So Kevin says Moon Month for up for that. Yes, indeed. All right, let me put a few of these up on the screen so I can say thank you. So Kevin says up for that. Ian says great idea. Kenneth says yes, indeed.
Graham says go moon.
Graham says yes, go moon. Anybody else want to say yes or no? We'll just give that a bit longer. Sandra, yes, please. Thank you all for that. Anybody else be interested in Moon Month? Because there's so much happening in lunar exploration over the next few years that we thought we'd set the scene for it, if you like.
Yeah.
By telling you everything we possibly can about the moon. We're going to try and get some specialist guests in to talk about the moon with a degree of expertise. Derek abstains. Jerry says yes. Anybody else? So thank you, Tess.
Yeah.
Yes.
Well done, Tess.
Yeah. Gerard says yes.
Yay.
Well,
resounding yes.
Yeah.
Ooh.
So I think the eyes have it, basically, don't they?
Hey.
So
The eyes have it. The eyes have it.
the eyes have it. Order. Okay, mine's a fine. So, well, that's what we'll do then. We'll do Moon Month, and we're thinking of doing Moon Month starting at the beginning of April, which will give us time to put everything together.
Yeah.
So thank you all for letting us know your views. We will definitely do that. And Alan as well.
Alan says yes.
Alan says yes.
Thank you, Alan.
And Paul says Zybe. Yeah. I think that's it. Yes, maybe. Yes, sorry, Paul. He's come back and said yes. Nazmal says, thank you, Nazmal. That looks like a yes to me. So, thank you, Nazmal. Thank you very much. Great. And yeah, definitely. So we will do Moon Month in April. We will put everything together in March and get as much as we can. And we've got a long list of things. Derek made a good suggestion. We could do a moon quiz.
That's a good idea.
Yeah.
Ooh.
Yeah, because we know we love quizzes.
Can I write that one?
Can you write that one? Yes, of course you can. There you go. You just volunteered.
Oh dear.
So great. Okay, so Space Oddities Moon Month, that settled it. Thank you, viewers. Thank you for helping make that decision. And April is Moon Month on Space Oddities. Tell all your friends. Ring random people in the phone book and tell them. So
what's the phone book?
Yeah.
Oh yeah, what's the phone book? That's
Fly Fishing by J.R. Hartley.
Yeah. It's many years since I think we had phone books left outside the door. That's never happened in Spain. Actually, they never delivered phone books in Spain.
Oh right.
No, so
it's obviously a British thing.
Okay. So yes, so we can do a moon quiz. Great, as part of that. But yeah.
Oh, Ian says not Michael.
Not Michael. Yeah.
I'll do one.
Sorry, Ian, I'm still doing it.
Poor Michael. Have some sympathy for Michael. He went to the doctors today for a checkup on his broken fibula, and the doctor said he's doing well. And you hope to be back driving soon, don't you?
Yeah, well, unfortunately, I've got to wait another 4 weeks.
Yeah.
So, yeah.
Well, kick death off the roads, eh?
Yeah, exactly.
So yeah.
You won't see me.
Hey, Paul, no problem. Paul was so excited he misspelled yes as YZ. But
yes, you won't see me on any dance floors anytime soon.
Thank God.
Thank God.
Yeah. So
Rachel will be happy, Michael. Rachel.
but Michael did well at the doctor's, and the doctor prescribed him hot yoga. Which, we've all been very, very interested to find out what hot yoga is.
Yeah,
And
I will.
His little beady eyes have just been shining since then. Yeah, Sandra says this would be a good title for the month: Mooning on Space Oddities.
Oh my God!
I thought this was a family show.
Whatever gave you that idea? All right, it's time to go with Roger, I think. So,
Yeah.
Oh no!
yes.
Bring us down to earth.
Yeah.
Oh,
So as
yeah.
I said earlier, we only had one image sent into the gallery this week. So it's always commensurate with bad weather in the UK. When it's good weather, people get out observing, and when it's not. And I know you've been a bit cloudbound in the UK. So as soon as it clears, guys, get out and take those images because we want to see them. And
Yes.
as always, just attach them to an email and address them to gallery@spaceoddities.space. So there we are. All right, Roger. I know it's a small gallery, but of course the night sky never stops doing things. So what have we got this week?
Well, if there was ever there were some clear skies this evening before I came on, so that's typical.
Oh, yeah, that always happens to me. Whenever it's Space Oddities night, it's always clear.
Right then, presentation, please.
Okay.
Next
Cool.
slide.
Here we go.
Right. Okay.
First slide.
That's right. Hang on.
Here we go. Right, so we are for the 18th to the 24th of February, so coming out to the end of our second month of 2025. Right, so we are currently experiencing a waning gibbous moon to a crescent by next Monday, so it is rising up tonight, I guess around about midnight, so and it won't be up too high in the sky, but there we go, so not too much of a problem, hopefully. So we do have during this week, this is currently at 8 p.m. through the week, we do have Orion gloriously visible in the southern horizon. We have Venus still quite nicely positioned during the early part of the evening, and Jupiter and Mars dominating the skies quite high up in the southern area, so all's well and good really to get some planetary imaging and view of our favourite constellations. So through the week we have got through. Now before sunset, we do have Mercury now trailing away, heading towards Saturn, and we've also got Neptune and Venus, although that will be rather difficult during the daytime hours. So there is an opportunity possibly of carefully observing Mercury, although it's still relatively close to the sun. But Venus, as we all know and love in the evening sky, dominating the southwestern horizon. So keep an eye out. But later through the week, as you see through this, on the 24th, Mercury and Saturn are quite close together.
Oh, yeah.
So that might be an interesting challenge for a Mercury-Saturn conjunction there. So that might be possible, but you obviously need a good, clear horizon to be able to get that. But if anyone's up for it, show me in the gallery. And just to top it off, here's our lone entry from Jerry Delay of the NGC 6820 emission nebula surrounding the open cluster in Vulpecula. Now, I'm not quite familiar with this one, but Jerry has demonstrated his skills and posted this image of it for us.
That's wonderful.
Oh, wow.
That's
Mm.
God, look
There
at those pillars.
Mm.
Amazing.
I shall-
Well done, Jerry.
I shall-
Another winner.
Well done. That's all I can show you for this week, unfortunately, but maybe next week we'll have more to see with clearer skies.
Right, well, thank you very much for that, Roger. Let's just ditch that. Okay, so we move on now to what has become a regular feature on Space Oddities. Fanfare, please. It's time for Constellation of the Week. And this week is Michael's turn to tell us about a constellation. And in true Michael style, he's chosen a really, really, really easy one, which is the Triangulum constellation.
Correct.
So when you're ready, Michael.
Yes, I'll be there in a secondo.
And
Okay.
did you know, the interesting fact about Triangulum, there are 3 main stars in it. So, yeah.
Okay, so here we go with Constellation of the Week. And tonight, as Andy says, it's Triangulum. I thought I'd try a easy one, I think. Okay, here we have Triangulum. Can you see my cursor there? Good. Nestled between Aries and Andromeda, so quite easy to find in the night sky, although not exactly bright stars in there. It's better with obviously a dark sky side to view Triangulum. Whoops, sorry about that. So Triangulum is the 78th constellation in size, occupying an area of 132 square degrees, and lies between Taurus and Andromeda, next to another small constellation, Aries. Okay. Known to the ancient Babylonians and Greeks, Triangulum was one of the 48 constellations listed by the 2nd century astronomer Ptolemy. So, history there for you. This is a map from Sky and Telescope magazine. It's the standard black and white, black stars on white background that astronomers easier for astronomers to use when observing it at night, of course.
Of course.
And of course, being next to Andromeda, it's not too far away in the sky from the Andromeda galaxy as well. So a good area of sky to observe. As Andy says, Triangulum consists of 3 bright stars, hence the name, and a spiral galaxy M33, but also has several other stars. Okay, this is a screenshot from Stellarium, and showing the 3 bright stars, Alpha, Beta, and Gamma, and go through those now. 3 bright stars. Whoops. Going to start again. The 3 bright stars are no brighter than magnitude 3. The yellow-white alpha trianguli is a rotating ellipsoid variable at magnitude 3.2. But like Orion, which I did a few weeks ago, Alpha Trianguli is not actually the brightest star. But Beta Trianguli is, this falls to Beta Trianguli, a white star of magnitude 3. The variability of the Alpha Trianguli is probably the reason, similar to Betelgeuse in Orion. Okay, so then we have Gamma Trianguli is a white star at magnitude 4. So those are the bright stars. There are 19 other stars brighter than magnitude 6 within the area of Triangulum. So quite a lot to explore still there. Okay, so within Triangulum, you've got a spiral galaxy. This is known as Triangulum Galaxy, otherwise known as M33. This is an image taken by the VLT survey telescope at ISO's Paranal Observatory in Chile. Okay, so that's the Triangulum Galaxy. It's the 3rd largest galaxy in member of the local group of galaxies behind the Andromeda Galaxy and the Milky Way. Oh, okay. Oh, and that's all I've got for Triangulum. So,
right. Okay.
Do you want me to go through the eclipses now?
Yes, please. Yes, why not?
Yeah. Okay. Just let me stop that share and go to another one.
We've got a few eclipses coming up, viewers, that
Yes.
give you some more information about.
Nearly there.
Okay.
Okay.
We've got a lunar eclipse and a solar eclipse coming up.
Hold on, it's not there. Where is it not there?
Unfortunately, I think the lunar eclipse is not really visible in Europe, or
Correct,
not
yes.
visible in Europe.
So, okay, is that there?
Yep, that's that.
Right. This is mainly for our American or Canadian viewers, if you like. On the 19th, on the night of the March 13th, 14th, 2025, total lunar eclipse will be visible in North America. In the United Kingdom, the umbral part of the eclipse does not begin until after daybreak on the 14th. This is also called a blood moon because of the deep red colour caused by the refraction of the sun's light through the Earth's atmosphere. This is a diagram showing, basic diagram showing the sun's rays causing and the Earth causing the shadow that causes the moon to go red. As I say, you won't see that from England or the UK because it will be still, it will be daylight by the time the umbra gets there. But this is a nice diagram from timeanddate.com. But what I've included here is details of the eclipse from Pittsburgh, Pennsylvania. So that will be in Eastern Daylight Time for anyone in the northeast United States. So the partial begins at 01:09 local time. Full eclipse or umbral eclipse starts at 02:26. Maximum at 02:58, and the full ends at 03:31. The partial ends at 04:47. So nighttime in the US is the best place to see this from, as well as Canada. You should get a good view of that as well. So good luck to any of our viewers in that part of the world, and if you do see it, send us any pictures. So okay, so this is the total eclipse of the moon from the UK. We do see the penumbral part and the partial part of the eclipse, but the sunrise, as you can see there, is 06:25 on the 14th of March, and the full eclipse starts a minute later, as it were. So just to confirm that is the details from the UK. Okay. And this is a map again from Time and Date showing how much of the United States and Canada and Mexico, of course, can view that eclipse on that date. So good luck if you're viewing that. Okay, we now come to another eclipse, which is well placed for UK observers. This is on Saturday the 29th of March, and this is a partial eclipse of the sun beginning at 10:30 GMT. Or beginning before 10:30, goes on until 11:30. Maximum eclipse around 11 o'clock. You can see this is a diagram showing how the sun and the moon will be viewed from Earth, and the moon blocking out the sun's light, of course. This is a diagram I pinched from the web as viewed from Darlington. So, Rachel, this should be okay from where you are, I would have thought.
Yeah, perfect, absolutely perfect. And that's the 29th.
Yeah, so GoStargazing.co.uk are making 75,000 pairs of solar glasses available across the UK to ensure people can safely observe this event. We always say, please do not look directly at the sun unless you've got the appropriate equipment in place, proper solar filters, or you're actually projecting the sun from a telescope. Yeah, please do not look at the sun directly. It could be quite damaging, and it could cause blindness. So there is a web address here that will let you order these solar glasses at very reasonable cost, and I'll put that address in the chat. So that's gostargazing.co.uk in association with firstlightoptics.com and astronomerswithoutborders.org. So anyone doing outreach is a great one for outreach because it's on a Saturday morning, late Saturday morning, so brilliant time to get families involved in viewing an eclipse of the sun. So that's a good one for that. This is Neil Sanders of ghoststargazing.co.uk promoting the 2017 eclipse glasses they made available, and the new ones for this year will be very similar to this, obviously with a different date. So that's the only picture I have of them, I'm afraid. Just before I finish, got a date for your diary, the 17th of May, Saturday the 17th of May, the Federation of Astronomical Societies are holding their latest astronomy convention, which will be held at the Institute of Astronomy, northwest of Cambridge, at the Madingley Rise site, Madingley Road, Cambridge. Doors open at 9 AM with the programme running from 10 AM to 6 PM. Tickets for FAS members are £10 per person, £5 on the 16s, etc. That's FAS society members. It's a society that's a member of the FAS, and in turn, because of that, each member of that particular society is also a member of the FAS. So there will be an online booking system coming online shortly. Just got to wait for that to get set up. So big thanks to Jerry Stone, meetings organizer for that particular event, and Claire Lawries, our FAS president. So that's good for that one. For those that you don't know, I edit the FAS newsletter, which comes out 6 times per year. So quite a thing, an event that I'll be involved with as well. So hope to see you somewhere on that. Just before I finish, I also produce a magazine called Capcom for this time for SpaceOddities. Capcom is also published 6 times a year. It's now free to subscribe, and all you need to do to subscribe is send an email to capcom@spaceoddities.space. Subscribe in the subject, and you will be added to the mailing list. So that's a couple of images there of the recent issues. So again, that's a free magazine, mainly about space flight and rocketry. A little bit of astronomy in there occasionally, but yeah, if you're interested in that, then just sign up. We'd be glad to have you. So, and I think that's it.
There we are. Thank you very much for that, Michael. And you just stop sharing your screen. Then, yeah. Okay, so that's it. Lots of information there. If you do make the FAS event and you take photos, send them into the gallery.
I aim to be there.
Don't let that put you off, viewers.
Driving permissible, of course.
Yeah, absolutely. If you can drive by then. But seriously, if you go to any of these astronomy events and you take images of the events, send them to us, because the images don't have to be about things in the sky.
Okay. So do we want to ask Tom about his Picastro again?
Yeah, I was just coming to that. How's the Picastro app going, Tom?
Yeah, really good. Lots of people joining all the time, so that's really exciting, and there's a good mix of beginners as well as intermediates and experts on there as well, so that makes me happy. In fact, I was just responding to, there was another handful of reviews on the App Store today, so I was just responding to those as well, and it's really nice to read people's feedback on how positive the community is, how everybody's kind of there's no there's no agenda on the app. That makes it really exciting. There's no agenda at all. It's just really great people sharing, really great learning, and really great images, which is fantastic. So yeah, it's going really well.
Because everybody taking up astrophotography as a hobby, if you like. I mean, everybody has to start somewhere.
Yeah.
And you know, when you have a community like that where people can learn from each other, it's incredibly valuable. It really
Oh
is.
my goodness, it's amazing.
And in the latest FAS newsletter, there will be a 2-page spread review or details about Big Astro. I haven't got it in front of me at the moment, but yeah, so there'll be a 2-page spread of that. Brilliant. Thank you for that, Tom.
Yeah.
Thank you.
And, tomorrow, Tom, I hope to find the time finally to add a page to our website with details of the app as well.
Oh,
I've got that earmarked for tomorrow. So there we are. For those of you that didn't join us last week when Tom was talking about Pick Astro, then have a look at last week's show and he explains everything. But to be honest, if you go to the website, whose address just came up on the stream, pickastroapp.com, it's the website is really well laid out and there's a great explanation of exactly what the app does, and you can learn all about it there. And it's free, although there is a tier level, there is a pay level. But if you want to join up and you have a wonderful community to share your astro images with in a completely uncompressed format, which is also
Here's another review, guys.
Oh, there we are.
Yeah,
highly recommended. That only cost us £10. So, you know.
Thank you, Ian.
Yeah, thank you, Ian. Thanks for that. And, no, Tom has done a great job. Tom and his developers have done a great building that app online.
And just to add, Lou, as well, there's a tablet version coming out in about 2 weeks.
It does. Yeah.
There we are.
Yeah.
So it's available online on the website as an app, and shortly a tablet version. So best of luck.
Yeah.
So we hope to see a lot more of Pick Astro app, because as far as I can make out, it's unique on the, there's nothing else like it.
Just don't take the tablet version with water.
Moving on. Moving on swiftly. So that's it. So anyway, I think that's about it from us for tonight. We will, of course, be back at the same time next week, and we'll obviously advertise what we're going to be getting up to next week. But thank you all for telling us that you would support the idea of a moon month.
Moon month.
Yeah. Oh yes. Now that's worth mentioning. Who's Who in the Moon by Brian Jones and Catherine Ray.
Yes.
And
That's A to Z of who's named on the moon and the story of that person that is on the moon.
Oh,
very good.
And one of my family's got a crater on the moon. There's a crater Briggs. Well, there's a Briggs A and a Briggs B, I think. Named
Richard, hold that up again. Richard, hold that up again so I can take a screen grab of that, because I quite like to get that.
Who's Who in the Moon?
Got it. Thank you.
Yeah. Really, really good book.
Not only, but also.
Oh, that is good.
With Sir Brian May, with some of his writing in it.
Wow.
Mm.
And Andy Saunders has a new book. I bought his last book. It's a huge, big thing.
You need the glasses.
Yeah. So
not eclipse.
It's very good.
Not eclipse glasses though.
No, definitely not eclipse glasses.
The Who's Who in the Moon. Brian and Catherine are both friends of SpaceOddities.
Yeah.
They worked so hard on that book for a couple of years.
Yeah.
And it's finally in print, available wherever you see this sign. What?
I spoke with Brian today, actually. He's good.
Oh, really? Yeah, I spoke to him a couple of days ago, actually.
Yeah.
So there we are.
It's priced at £25.
£25. Bargain. Seriously, I mean, I was looking at the cost of new paperbacks the other day, and they're catching up with hardbacks. You know, it's outrageous. And moan. Anyway,
Yeah.
So, anyway, viewers, thank you all for being here. That's what I want to say. Your company on Tuesdays is much appreciated when you could be doing anything else, really. And we do enjoy you being here with us and taking part in the chat. And we want to say a big thank you to Paul and Gerard for their contributions this evening.
Definitely.
Much appreciated. And it will help keep the show on the road. And we are very grateful, obviously. So from all of us at Space Oddities, we hope you have a fantastic week. Hope the weather in the UK improves a bit and gets a bit warmer and clearer. And I hope I get another day like yesterday, where I was out in a t-shirt in 23 degrees full of sun. So
It's not even March yet.
I know. Well, you see, I judge the passing of the seasons by the date of the first day I can go out in a t-shirt without freezing, and it was yesterday, and that normally doesn't happen till at least the end of March.
Yeah.
So it was a big shock. It was a glorious day. I really enjoyed it.
Very jealous. Very jealous.
Yeah, I know. But that's life. I made my bed, so I have to lie in it, really, with all this fantastic weather and a summer that lasted 6 months. So it's
Is that the smallest violin in the world I can hear? Then, isn't it?
okay. Right, take care, viewers. Thank you all of us at Space Oddities, and we will get on to Moon Month now that we have the viewers. We have a reason for doing it, and we have a mandate to do Moon Month in April, so that's great. All right then, enough chat. See you soon, viewers. Have a fantastic week from all of us at Space Oddities. Thank you for being here, and good evening.
Take care, guys.
Night, everyone.
Keep looking up.